Now that I've presented the lists, I'll go into maps. Maps are a bit more tricky because the problem is that the meaning of an association is only that A has a number of B's here, but a key is missing for a map, so it doesn't express a key here. And one way to fix this using EMF and using UML is to simply create a class which stands for your entries. So an entry in a map, a key value pair. And for example, this could be an int to string entry. So an integer key and a string value. And I model this by creating two attributes. I create an attribute key of type integer, and remember we have to select integer object, not just a primitive type. And I create my property value with type string. So far so good. Now there are two ways to express that, for example, A has a map of this key value type. One is to draw an association, and there are a couple of things you have to consider. First of all, well, this will be your variable name, similar to the list that I had before. So I can call this, for example, my map. But now the important things. First of all, the multiplicities, of course, I want to have multiple entries, so 0 to many. And important is also that you set the aggregation to composite. So you have a composition, otherwise the code generator gets confused. That's the first way, and I'll create my gen model for that. Finish, everything is good. I press generate model code and I get something that probably doesn't make a lot of sense. We'll see. Yeah, so now EMF has generated a E-list of integer to string entries. So basically this is exactly what we did before here. It just creates a list. And that's not very nice. We don't want that. And in order to fix this, we have to do a trick. We have to open the eCore model that is also here. Right click, open with sample eCore model editor. So this is also being created when you create a gen model. And it's basically reflecting your class diagram. So you have everything you have before, and here you have your entry class, but you can add information that EMF uses for the code generation. And the only thing is that you add the instance type name. You say the instance type name in this case is java.util.map, and as it's an entry, it's only a map entry. And you save this. Now, when you reopen the gen model, you will see the same model. It's just being loaded in here. So here you have your entry, and you can right click generate model code, and hopefully now I will see the proper thing. Yes, so now we have an EMAP of integer to string. And that's one way to do it. The other way is simply that you can add a property. So similar to what we did with the list before, you can add a property here, my own map, and you can assign the type to the integer to string entry. And now, similarly to what we did with the arrow, you have to set the multiplicity to many, and you have to set aggregation to composite. Save. We recreate the gen model. If it doesn't show reload for you here, then you're in the wrong view. Then we can just go to the Java perspective, for example, and there you can say reload on the gen model. And hopefully everything works. Yes. And you get your new gen model. And now, of course, the problem is that here the instance type name has been removed again. So this can be a bit annoying if you have multiple of these types, but you can simply add this again. So same as before, Java util map entry, and that's all we need. So now we can generate the model code, and we should in B also have a map. So that's the map part. And of course, instead of using integer or string as key value, you can also use your own objects. So we can say we want an integer. Let's rename it to integer to b entry. So we want to have a b in there. And we can simply assign the type to b as we have done before. But a nicer way, as we have it in the class diagram, is actually that we simply remove the value here, and instead we draw an association. And we don't call this b, what we call this value now. So now we express integer to b entry has a key, and it has a value of type b. And now I hope that this works as well. As planned, I go to my GAN model, I reload it, finish, and again I go to this model and fix the instance type name. I save and I press generate, and now something here is wrong. Yeah, this is still the remains from before. But generally, yes, this has worked. So now I have a map of integer to b, and the compiler errors here are only because there is some old things left that I have not fixed in the code generation. But otherwise, this is how you would do it.